Hey everyone, welcome to the Tektite-R robot tour run tutorial. First, one thing that I did include in the last video is make sure to put in this wooden dowel using these two screws they just screw in from the sides. One more thing that I forgot to mention in the previous video that I'll mention in this one is that now there's set screws in the wheel hub designs. So your kit will come with 2 or 3 of these set screws, and you'll see that in the wheel hub. Wheel hub is like this piece that went into your wheel. You'll see that in the side of it, in the piece that goes on the inside. On the side of it, there'll be a hole. So you need to take a 2.0 millimeter hex Allen key and take this set screw and put it into that hole and tighten it onto the shaft of this motor and make sure that the wheels aren't scraping the walls. And that basically reduces this backlash by quite a bit. All right. Now let's get on to the software that you need for this. You'll notice that I created a custom programming language in VS Code for programming your robot tour kit. So first, go to the extensions and search for Rotor and make sure you have this installed. Next up, go into here. Make sure you have Rust installed. So you should have the cargo command. Then you do cargo install Rotor. Wait for that to install. And now you have the Rotor command. So if you do, you should see that if you do Rotor, everything for the Rotor. Now let's start with the path. So I've set up this field on the floor here, and this is based off of the field in the rules manual. So I've created this track diagram here, which you can also find in the GitHub repository in the track diagram folder. And I'll have this linked in the description, of course. The way that I like to plan my paths is that I like to basically create a diagram of the field on this piece of paper here, and then just draw a path through it. So first, let me create a diagram of the field. All right, so now I've drawn out my field. So you can see we have the start here, we have the end point here, and I've drawn walls in all the appropriate locations to match the field. So now I'm gonna plan a path. And you really just wanna find the shortest path that goes through all of these 4 gates. So you just need to go in each of these, right? And another thing is that you should have all 90-degree turns. And most importantly, there's a last gate bonus. So last gate that you go through must be whatever is the last gate. Your event supervisor will tell you. In this case, this top right gate is the last gate. So I must go through this after going through all the gates and before reaching the end. So let me just find a path that fits that. All right, so here's one thing to keep in mind is that you can see that I can either go this way and then I can come back by going this way and down and this way, or I can go and reverse and go that way. And I'm actually gonna choose to reverse and go this way because as you can see, even though these are the same distance, this one will require just one turn, and that is over here because it'll drive forwards, drive backwards, and then turn and then go. Whereas going this way will require you to go turn left, turn right. So that's 3 turns. So by skipping those 2 turns, you can save some time. And you want to skip as many turns and have the shortest distance possible so that we can fit in the time. Now let's go on to programming this. All right, so we've got Rotor set up. And you should open up your USB flash drive and you should have a file impounded on it, right? And that file should be called, I'm just gonna call it test.rotor, but basically in the rules, it says they need to have a USB flash drive impounded with all your code on it. So you need to have a file named like whatever you want, .rotor on that USB flash drive. And then when you get to the event, you're gonna open that up in VS Code. So now let's go over the Rotor programming language. So it's really quite simple. The first thing you need to do is you need to write a time block. So you'll see that here's a sample code that I already made for this track, and you'll see that you start out with time 65. So I'm just gonna put that in. So now we've entered the time. Make sure you've entered a time, and will also be given you by the event supervisor, and the robot will try to follow this time exactly. All right, so there are 4 commands that we have for the robot: up, left, right, and down. And these are field centric, right? So let's just look at this sample path. So we start at the start, we go up 0.5, we go left. We just need to go left in this square, which is why I'm gonna say left 0.5, even though this path drawn actually has us going left 1. It doesn't really matter. But we've gone up 0.5, so from the bottom to the middle. Then we go left 0.5. Then we go up 1, left 1, 2, down 1, left 1, right 1, up 1, left 1, up 2, right 1, 2, 3, up 1, down 1, left 3. And bam, we're at the end. So you can see how this programming language really makes it easy to make a path. And I made this path, so you can see we got the time, up, left, right, up, left, down, and so on. And this should theoretically give us exactly all of the gates and bring us to the end. So let's try it now. So grab a USB-C cable, plug it into your computer, plug it into your robot, and do rotor run, and then put the name of the file. So for example, I'm going to have 2025.rotor. So you put rotor run and then the name of the file, and make sure you obviously have your terminal open up in VS Code in the correct folder. Then you'll see that one thing that you really need to pay attention to is this velocity, okay? If this number goes over 2000, the accuracy of a robot's really going to suffer. So make sure to keep this number under 2000. And this is basically just a function of the length and how many turns you have. So make sure to optimize your path so that you have the least number of turns, the shortest length possible. And if the track is just designed in a way that makes it impossible to keep that under 2000, or like close to 2000, then you might just want to skip the last gate bonus. Like you can see that if I had gone, for example, just through these gates and gone straight to the end, I could have had a lot shorter distance. So you might just have to skip the last gate bonus to keep it under 2000, or you might just want to get one run without the last gate bonus and then do another run and try to push that velocity. But anyways, when you push the code, you'll see that there's this cool little LED pattern, and then we can go run it. So the way I like to line this up is I take the dowel and I line it up with this dot on the start. You can just pick some random feature on the start, but you can see I have it lined up. Next, make sure to bring the wheel. You'll see that they have a little bit of backlash, right? So just make sure to push it so that's at the back of its backlash range. So you'll see this is forwards, this is the back. So put it at the back, put it at the back. Do both wheels at once when you have 2 hands available. Make sure that you've lined it up with the tape. So you can see that this is not lined up. I'm gonna bring it back like that, and that looks really straight. Wheels are the back backlash, power is on. Let's run it. So this red LED is on. That means that the battery voltage has dropped below 5 volts. This might happen in some like pretty long segments of your code, but also if you see this happening really commonly, that means that you need to charge your batteries. So after this, I'll probably charge my batteries. You'll see this little end script to give us the right amount of time here. Now you'll see that we actually overshot and missed the endpoint quite a bit. So let's just keep my finger here, and you can actually ask the event supervisor to measure this for you. But I'm gonna keep my finger here and move the robot out of the way. Now grab a measuring tape and measure it. So you can see that we are about 7 centimeters too far down. let's say 12 centimeters too far left. We need to go 8 centimeters further. So I can write, you can have comments by the way. So you can do, we need 8 centimeters up, 12 centimeters left, just so I don't forget. So let's see. So we want to go up when we get past the gate C. And you'll see that I've actually commented when we go through certain gates, such when I was writing this. So now we can just see that when we go up through gate C, we actually want to go 8 centimeters further, right? 8 centimeters out of 50 is 0.16. So we say we want to go 2.16. And the reason you do out of 50 is because each of these is 50 centimeters. So we want to go 8 centimeters further. And we want to go 12 centimeters less this way. So you can see that we have this left 2 over here where we go from here to there. And the reason that I've done that is so that our end script, the slow part, is only going for a very short distance. So we can see in here to here, we want to go 12 centimeters that way, right? So we want to go 12 centimeters this way. 12 out of 50 is... So we want to go left 1.76. And that should counteract the errors we had on our original point over here. We'll be going less this way, and we'll be going more up. So let's push the code and try again. So you can see that the velocity is still pretty much the same. Line it up. And I would just count that first run as probably a failed run, since I'm pretty confident that we can be more accurate. And that way it won't count towards your 2 minute, your 2 successful run limit. So that's a failed run. Hopefully this will count a successful run. Let's start it. You can see it's already red, which means I really need to charge my batteries. Alright, so that was actually quite a bit off. And I'm just gonna I think that this inaccuracy is coming from the batteries, because I expected only to be an inch off. So I'm gonna go charge the batteries. The batteries are charging. Let's talk about another source of error, and that is these wheels. You can see that they literally pick up so much dirt. They're extremely dirty now. So we need to clean them off. In fact, they've actually made the bottom of this quite dirty. So the way they clean these off works really similar to the electric vehicle. You take a damp paper towel and wipe to the sides. And then you take a dry paper towel and you dry it out. All right, here's a damp paper towel. Let's start wiping. And normally I'd hold this up in the air and wipe it, but unfortunately I only have one hand. All right, so I think I wiped the whole thing. This is really dirty now, so let's grab a dry paper towel. Dry paper towel here, and let's just wipe it. Alright, so here you can really see the difference. Now here is basically just green, while on the other side that I haven't cleaned yet, you can see it's just super dirty. And I can also feel that this side feels much stickier than this side. So I'm gonna go clean the other side now. Right, so I've cleaned both wheels, and I bought a pack of 8 NiMH batteries, and I'd recommend you do the same, which allows me to just change out the batteries to some fresh ones without having to wait for them to charge. So let's try that again. So it doesn't turn on, and I think that has to do with this battery pack. I don't really like it. You can see that there's a little gap of air in this battery because the spring isn't strong enough. So I push it that way, push this one that way. See that now it's turned on. So let's run it. Make sure to clean off your wheels and change out your batteries before you go to the competition day, because You obviously can't clean them and change them like I've done today. Alright, so you can see that we've ended up quite a bit this ways. And this actually matches what happened before I changed out the batteries and cleaned the wheels, which means that I think that the first run was actually the mistake. So at this point, you can see that this is about 7.5 centimeters of error, which makes me believe that I should just get rid of that 8 centimeters that we added, and we should be able to get a good run. But I would probably count this run as a success because the time is basically spot on, which means we'll get about 8 points. At a regional level track like this one, that means you get 118 points, which I'd say is pretty good, but we'll get rid of that 8 centimeters that we added earlier and see what happens. All right, let's start it. Let's see. This is about 5 centimeters of error, which is what I found is acceptable with this kit. So after 3 runs, we're able to get 5 centimeters of error. I believe that I would probably just add it to make it go a little this way and probably do another run if this were a competition. But and of course if time permits. But this has been the run tutorial. Make sure to clean your wheels and charge your batteries before every competition, and good luck.